working with a CNC milling machine, tools of various lengths and sizes are used, along with workpieces located at different positions within the machine. In today's video, we'll learn how to set work and tool offsets using an edge finder and a Z-axis tool height setter. Let's review the lesson objectives. By the end of this video, students will be able to jog the machine carefully in all three axes of motion using various jog increments, set X and Y axis work offsets using an edge finder, and finally, set the tool length offsets by referencing tools to the top of the workpiece. Before we begin, we should note that the methods shown in this video are not the only ways to set tool and work offsets. There are many valid methods. We've chosen to show a few that work well in our shop. Your shop's standard practices may differ, so check with your instructor or shop supervisor before setting or changing any work or tool offsets. Caution: improperly set work or tool offsets can lead to catastrophic machine crashes. Be sure to verify all offsets when running a program for the first time or after any offsets have been changed. Let's start with the edge finder to locate our XY work origin. With the spindle stopped, bump the edge finder so that it will wobble when spinning. Put the machine in MDI mode and enter a spindle speed of 750 RPM with a command of M3 to turn the spindle on clockwise. Close the door and press cycle start. The edge finder will start spinning with a wobble like this. Now, let's handle jog the Z-axis downward to approach the workpiece. Use caution when jogging. Position the X and Y axes so the edge finder can be brought behind the part. Switch to a slow jog increment of 1/1000th when approaching the workpiece. While still on the slow jog increment of 1/1000th, carefully jog the Y-axis so the part contacts the edge finder. As contact is made, the wobble will diminish until the edge finder begins to rotate smoothly. Slow your jog speed on the hand wheel. We're looking for the point at which the edge finder just jumps off to the side. There it is. When this happens, the edge finder is tangent to the edge, and we should stop jogging in that direction. Press the current command's display key and press page down 3 times to bring up the coordinate display. With the edge finder still touching the part and jump to the side, press the origin key to zero out the Y-axis operator coordinates. Now, slowly jog the Y-axis away from the edge finder. Stop the spindle and bump the edge finder to prepare for locating the X origin. This time, we'll press counterclockwise. Unlike cutting tools, the edge finder can be rotated either direction. Jog the X axis to position the edge finder beside the part. This display features 4 coordinate systems: operator coordinates, work coordinates, machine coordinates, and distance to go. Pressing the cursor down will display one coordinate system at a time with very large numerals. Slowly jog the X-axis toward the edge finder using a small jog increment of 1/1000th. Watch for the edge finder to rotate smoothly, then all of a sudden jump off. Because we chose to rotate counterclockwise, in this case it'll jump forward, which is easier to see. There it is. Press origin to zero the X-axis operator coordinate. Carefully jog the X-axis away. Stop the spindle now, because we're done touching off. Jog the Z-axis so the edge finder is well above the workpiece. Now jog the X and Y axes until the operator coordinates display 0 for each. There we go, 0 for X and 0 for Y. The edge finder is now located near the corner of our part, but there's still a few more steps we need to do. Let's go to the whiteboard. Here's a recap of what we just did as viewed from above. Here's the back face and the left face. First, we touched the edge finder tangent to the back face, and we called that our Y coordinate 0. So if we draw a temporary axis through the center of the edge finder, that's our Y 0. Then, we touched tangent to the left side face of the part, and we called that our X 0. If we draw a temporary axis like this through the center of the edge finder, that's our X 0. So if we look at the intersection of these temporary X and Y 0 axes, we find ourselves here, which is currently our X and Y 0 on our operator coordinates. That's where the edge finder is right now. This is a point in space which isn't a very useful reference. We need to shift this point to the actual corner of our part. So, we need to move it in the positive X and negative Y directions by the radius of the edge finder. Edge finders come in standard sizes. The tip of ours has a diameter of 0.2 inches. Therefore, the radius is half that, or 0.1 inches. Once we make that shift in positive X and negative Y, our edge finder will be positioned with the center of the machine spindle directly over the corner of our part. We're going to call this new location our actual X and Y 0, known as G54. G54 represents the work coordinate system, and X and Y 0 is the part origin. Now let's make that adjustment on the machine. With the edge finder above the part, physically jog the machine 0.1 inches in positive X and in negative Y for this corner. You can see that the X operator coordinate is at 0.1 and our Y is at negative 0.1. Visually verify that you jogged in the proper direction. The final step is to tell the machine that this location at which we currently sit should be known as the G54 origin. To do that, we need to enter the offsets table by pressing the offsets key. Press the key again to activate work offsets. The display panel with the white background is the active panel. Move the cursor to the X-axis column of the G54 row and press Part 0 Set. When you do, the machine coordinate for the selected axis column will be transferred to the offset table. Press it again to set the Y-axis. For Z, we don't want any value entered in there. To zero it out, type 0, then press the F1 key to overwrite that value into the offset table. A dialog box will appear saying, "Warning, greater than setting 142, except..." Setting 142 is the maximum allowable change to offsets and is typically a somewhat small value. We did mean to make this change, so we'll press Y for yes or enter to confirm. The 0 value is now entered for Z. Notice, with the G54 set in the offset table, our current command display now shows that we are indeed at the G54 X and Y work origin, or part 0. Now, let's say we take the machine to its G28 home position. Now we are at machine 0 in all three axes, and we are some distance away from our work 0, about 13 inches in the X and 4 inches in the Y. Let's command the machine to move back to its work origin in X and Y. Press MDI, then clear any existing codes by pressing the Erase Program key. Enter the following code: G0, G90, G54, X0, Y0. Notice there are no Z moves in this code. Let's take a look at each command. G0, rapid traverse. Move as fast as possible. G90, use absolute positioning, one fixed origin. G54, apply the work coordinate system number 1. X0, Y0, move to the origin. Enter the code into the MDI window and verify it one more time before pressing Cycle Start. The machine moves to the X and Y origin. Jog the spindle down to verify the origin is in the intended location. Our display shows we're at the origin, and a closer look verifies that indeed we're over the part corner. Wherever we jog to, the machine still knows the corner of our part as the G54 work origin, and if we run the same code again, the machine will go right back to that corner. Here's a closer view. Suppose we wanted to check where a different work origin is, such as G55. We could alter this MDI code to use G55. With the tool high enough to clear any work pieces or fixtures, press Cycle Start. It looks like G55 is being used with this second vise. It's very common to use multiple work offsets for multiple fixtures. Now, let's take a look at setting our tool length offsets. In this example, we have not set a work Z offset for G54, so we'll set all our tool offsets to the top of the workpiece. We're using a 2-inch dial Z-axis height setter with a spring-loaded touchpad. Place it on top of the workpiece and jog the table so it's underneath the tool. Carefully bring the Z down using a slow jog increment of 1/1000th until the tool contacts the touchpad. Continue jogging until the needle reaches 0, being sure not to go past. Switch to the 10,000ths jog increment for finer adjustment. With the needle at 0, press the Tool Offset Measure key. Now, we need to account for the height of the instrument, which is 2 inches. Input -2 point enter. We get a dialog box saying the change exceeds setting 142. Press enter to accept the change and double check that your tool length offset is exactly 2 inches more negative than the machine Z coordinate. Press and hold the Z-axis positive key to jog the tool away from the height setter. Close the door and switch to the next tool. Let's repeat the process. Jog the tool down. Switch to the 1/1000ths jog increment and continue jogging until the gauge reaches 0. Switch to the 10,000ths jog increment. Press Tool Offset Measure. Subtract 2 inches, being sure to include the decimal point. Accept the change. Verify the measurement. Jog the Z-axis positive away from the height setter. Switch to the next tool. See if you can narrate the steps this time. Great. This concludes setting the tool length offsets. This process would be repeated for each tool used in the program. Now, let's verify our tool length offsets by entering a few codes into the MDI window. Clear the MDI window and enter G0, G90, G54 with no X, Y, or Z coordinates. This line of code ensures the machine is operating with absolute positioning with respect to the G54 work coordinate system and turns on rapid traverse motion. On the next line, enter G43, an H number, and Z0. The H number should match the T number of the active tool in the spindle. This line of code turns on tool length compensation, applies it for the length offset number 3, and moves to the height of Z0. This motion takes place rapidly, as fast as the machine can go, because it's still operating under the modal G0 command from the prior line of code. Set the rapid override to 5% and keep a thumb on the feed hold key in case anything doesn't seem right. Press cycle start. The Z-axis will move downward and should stop when the tip of the tool is at the same height as the workpiece. If it doesn't stop at the top of the workpiece, press feed hold. Any movement below the surface of the work indicates the tool length offset and/or work Z offset is not properly set and needs to be redone. Ours looks correct. The process can be repeated for each tool by changing tools using the ATC keys and altering the H number in the code. This concludes our video on setting work offsets with an edge finder and setting tool offsets to the top of the workpiece. As previously mentioned, this is only one of many ways to set work and tool offsets. Be sure to check out our next video where we use the Heimer 3D sensor probe to set work offsets and where we set tool offsets from the machine table. Thanks for watching, and we'll see you in the next video.